All right, let's talk about section 1.9, which is solving 3 by 3 systems of equations. 3 by 3 means 3 equations with 3 variables. Now, this first page you can read on your own, and if you have any questions about it, you can certainly drop me an email or ask me in class, but I want to move directly to the problems. Here's the first problem, and what I want to do here is sort of walk you through the steps, but I'm going to do them rather quickly. So I'm going to pause the video when I'm writing and then unpause it when I want to speak. So the first thing we're going to do is to actually take one of the equations and isolate one of the variables. Doesn't matter which equation, doesn't matter which variable. So I'm going to choose the first equation because it looks like it'd be easy to get x by itself. Okay, so I've isolated x. So what I'm going to do now is I'm going to take that equation where I've got x isolated, and I'm going to substitute that into both of the other equations for x. So my work with the blue is me plugging that into the second equation. The work in the red is me plugging that into the third equation. So what I've got now are these two equations which make a system. So what I'm going to do is take those two equations and solve that 2 by 2 system. So I essentially took those two equations that had y and z and solved them by elimination, and you can see my work here. So I got value of z of 4 and of y -5. So once I have those two numbers, now I can take those and plug them into any one of the original 3 equations to solve for x. And I'm going to plug it into this version of that original equation. And then I'll write my answer as an order triple with x first, y second, and z third. Now, the process of solving by elimination is pretty much the same, but the first step looks different. So let's look at that. Those two equations that I got, so I'm going to use the same system that we just did, but I'm going to solve it by elimination. So with elimination, instead of getting one of the equations by itself and then plugging that into the other, which gave me two equations in y and z, this time I'm going to work to eliminate a variable and then eliminate the same variable in a different pair. And you'll see what I mean by that in just a second. So my first step is to pick a pair of equations and eliminate a variable. And then that gives me an equation in y and z in this case, so equation in 2 variables. To get another equation with the same 2 variables so I can do the system solving that I did before, I'm going to pick a different pair of equations and eliminate the same variable. It's really important that you eliminate the same variable so you end up with a system of equations that have the same variables left in them. So what I want to point out now is if I were to compare the two equations that I just got with what I did when I was doing solving by substitution, are identical. So every step from this point forward is going to be the same. We're going to solve that resulting 2 by 2 system and then use those two answers to find the third value of the variable, and then write your answers in order triple. Okay, so let's move on to a word problem. So let's move in here. So you can pause the video and read the problem. All right, so the first thing we're going to have to do here is what we always do when we're solving an equation like this. You need to calculate what it is, you need to define your variables first. So defining your variables says, what is the question asking for? So it says here at the end that we want to calculate the ages of everyone in Danny's family. And there are 3 people. So basically what I want to do is define my variables here. So I'm going to say x is Danny's age. I'm going to say y is his dad's age. And z is his mom's age. So now I need to go through and look for those sort of total numbers or relationships between things in the problem. This is like highlighting the information that came from the last set of guided notes. So we have, first of all, the sum of their ages is 94. So that's going to have an equation. The sum of ages is 94. And then Danny's dad is 1 year older than 3 times Danny's age. So that will be an equation. And then his mom is 6 years younger than his dad. So let me mark that, and let's say blue. Each of these things is going to have an equation in it. All right, so let's look at the first one. The sum of their ages is 94. Well, that one's pretty straightforward. You add the ages together, and that gives you 94. Now, let's look at the second piece of information. Danny's dad is 1 year older than 3 times Danny's age. Okay, so it's Danny's dad, his age is Y. So Y is 1 year older than 3 times Danny's age. So that will be 1 bigger than 3x. And then the problem says his mom is 6 years younger than his dad. Well, his mom is Z, his dad is Y, so mom is 6 years younger than dad. So if I were to take dad's age and take 6 away, it would be mom's age. So what I have here now is a system, and there's a couple of ways that you can solve this system. I look at this and I go, okay, I could do this by substitution, but it may take me multiple steps. So what I'm going to do is I'm going to look at that x plus y plus z, which has all the variables in it, and I'm going to look to get that down to one variable. So I see right now that y can be replaced with 3x plus 1. And z can be replaced with y minus 6. Because that's what this was. And that would equal 94. Now, we've gone from 3 variables down to 2, so that's good. But now we need to go from 2 down to 1. So I see that I've got this y that's here. So what I'm going to do is take the information that I know about y, and I'm going to replace that y with this information. So let's see, x plus, I'm just going to change this back because I'm not focusing on that, and then so that's what it would look like if I substituted. Now I have everything in terms of x. So what I'm going to do is combine like terms and simplify this. So this would be and then I would combine like terms. So that would be 7x. We've got 1, 1, and negative 6. That'd be negative 4. That'd be 94. And so now I can solve. So x is 14. Now I can take that and plug it back into something that has just 2 variables in it to find another one. So if I tried the bottom one, there's no x in that. If I tried the top one, there would still be a y and a z. So I'm going to look at the middle one this time. That's a 14. Let's make that clearer. So that would be 43. And now I have y, so I can use that here, or I could use the x and the y in the first equation. Either way would work. So now I have all the numbers, but remember this is a word problem, so I need to write the answer in words. So Danny is 14, Dad is 43, and Mom is 37. Now, you notice how I did this and sort of substituted stuff in. Keep in mind when you're missing variables in certain equations, solving the system isn't always going to be as formulaic as it is in the first 2 examples where you could pretty much do all the problems the same. This will require a little bit of like paying attention to what you have, but keep in mind you're always trying to get it down to 1 variable, trying to reduce the number of variables you have in the equation by doing substitutions in these steps. All right, hopefully that helps, and when you get more practice in that, I think it'll be useful.